Alright, welcome back in Chemistry Video 2.5, looking at the uncertainty of data. Main objectives are to define, compare, and contrast accuracy and precision, and then to be able to describe the accuracy of your experimental data using percent error. Turn off those cell phones, put them away, turn off that social media, pause, rewind when needed, and write some notes in the margins if you need to. Go, go, go! So, accuracy and precision are two different things. So accuracy, that refers to how close a measured value is to the accepted value. So if you think about like a target, the closer you are to the bullseye in this case here, what you're supposed to try to get for, that would be considered accuracy. Precision refers to how close you are, how close your measurements are to one another. So, for example, if you're doing this again, if you're hitting the same spot of the target over and over again, not necessarily on the target, but you're hitting over and over again the same spot, your measurements, in this case, were close together. That's called precision. We really strive for accuracy and precision. You want to be close to the right answer and have them all your shots next to the target or next to each other as well. And you want to avoid having very different measurements and not being close to the right area. Okay, so accuracy, how close to the right answer. Precision, how close all your measurements are to one another. So here we're looking at some students here. They were trying to shoot for making measurements. Like they probably had a graduate cylinder and the actual answer is supposed to be 15 milliliters. And we're seeing how close their measurements were. They made 3 measurements, how close they were to this value and to each other. So try to figure out who was the most accurate and precise, who was the most accurate but not precise, most precise, and who was the least on all. So try to figure out and then unpause to see the answer when you're done. Okay, good. So let's take a look at these overall. So start off with Joyous Belvia. You can see that the values themselves are not very close together. So we would say not precise. Oops. And if you look at how close they are to 15, they're pretty far away from 15. Most of them. This one was pretty good, but these were not very accurate. So let's say overall, not very accurate, except for one. Monty Kirkwood here, his values were pretty darn close to each other, only off by a few hundredths. So we'll say that he was precise, close measurements. And they're also very close to being around 15. So Monty Kirkwood was accurate and precise. That was the best one. Joyous Belvia was the worst one. Carble here, you can see Carble's values are pretty darn close together, so it would say it's precision. However, they're not very close to what's supposed to be a 15. So not accurate, but it is precise. Then Josephine Frederica here, their values are relatively close to 15 here. They're kind of hovering around it, plus or minus 2/10. They're not as close to each other as per se. These ones are only apart by a few hundredths. Here are apart by a few tenths. So we would say not very precise compared to the other ones, but relatively accurate because they're close to the right answer there. That's kind of how you'll look at these when you try to figure out accuracy and precision. So when performing an experiment, you are striving for accuracy and precision. However, precision is oftentimes limited by the tools you have available to you. So, if you have the option to use a graduated cylinder that goes from 10 to 20, and there's 10 little marks here in between, basically going by ones in between there. And you have another device that goes from like 7 to 8, and again there's 10 little marks here between here. Those little marks are going by tenths. Having better precision because of more place values is what you would like to go with. So kind of keep in mind you want to try to find your tools that give you the best measuring capabilities. Error is the difference between your value, the experimental value, and the accepted value. So it's kind of like actually like the top of this equation down here. Your experimental value minus the accepted shows how much error you had. Was it, 10 apart? Was it 20 apart? Was it a tenth apart? So error is the difference in those two values. What we really calculate a lot in chemistry is the percent error, which describes how much error you had based on the accepted value. So we have this equation here for percent error. Sometimes we'll just put it as percent error like that. you take the experimental value minus the accepted value, and then you also take these lines here, which means the absolute value. So if you end up with a negative value inside of here, we really just care about the absolute value and don't care about the negative sign. Then you divide it by the accepted value, and you times it by 100, and you end up with what we call the percent error. So ideally, you're going for 0% error, which means you're right on the exact answer. If these are both the same number, subtracting them gives you 0, and 0 divided out gives you 0% error. The higher you go, the worse off you were. So here let's try to find the percent error for Monty's average measurements. Okay, so Monty's average measurements means we're going to take these three measurements here, add them together, and if you have three measurements, add them together like so, and then there was three measurements, so divide by 3. And if you do that, you end up with 15.01 milliliters. So that's his average measurement there. Okay, so now to find percent error, because these were the experimental values, that's going to go right here in the equation. So we take 15.01 minus the accepted value, remember, was 15 milliliters, is what we're trying to go for. Absolute value of this divided by the accepted, which was still 15 milliliters, and then times this by 100. And Monty Kirkwood's percent error was, and it was pretty good, it was 0.067% error. So that'd be really, really, really good, having that low percent error, like I mean less than 1% error. Oftentimes you'll find your experiments in chemistry are probably some in the neighborhood of like 10 to 30. That's kind of what we shoot for. I mean, anything below 30 is pretty good for a chemistry lab. Alright, so that does it for our video on accuracy, precision, and percent error. Good job.